This is Paul. This is my colleague Paul, and the talk is also not about Paul. This is Paul's wife's aunt Dora. And Dora is a computer. We know this because it says so right on her marriage certificate from 1958. You can see her profession there quite clearly stated as computer. And I don't know if you've noticed, those of you with sharp eyes, if you look very clearly at the profession of her husband, you will notice that he is an engineer. So this is a situation where a computer has married her engineer. Now, Dora's story is a story of automation. And automation has been part of humanity's history since the beginning, since some human picked up a rock and banged another rock with it. We have been rebelling against drudgery since the dawn of our species. Whenever there's a way to do something better, we find that way. Now, that also causes change and it causes some upheaval. But we are constantly moving forward. I mean, think about it. Think about your jobs today in this room. How many of them would make sense to a medieval farmer if you tried to explain what it is that you do? They would probably not get it, am I right? But also, I want to point something out about Dora here. We never automated Dora. Dora's job, the computer, is now done by that device in your pockets. But it is not her, and it is not her human essence. It just does some of the tasks that she used to do so that people in her position can now get on with it and do other things. I'm fairly certain, I'm not gonna speak for you, but I'm guessing that you probably wouldn't want her job today. In any case, which is essentially adding and multiplying numbers together manually by hand. So we've automated Dora's job. And AI is another wave in this trajectory of automation. And like with Dora's story, AI, artificial intelligence, might sound at the beginning like there's some kind of notion of automating humans, personhood, robots, that kind of stuff. Now that stuff is more science fiction than science. Like with Dora's story, what AI helps you with is some tasks. And AI is actually a tool. It is a tool for writing software. So I want to show you what AI actually is and why it's exciting. So first things first. This is a picture of my pet Huxley. And when you look at this, you know that it's a cat. And if I show you this other one, you're not fooled. You still know that it's a cat. How do you know that? Your brain is taking in pixels, pixel data, which is actually stored on the computer as a bunch of numbers. And out of that, you suddenly understand that it's a cat. How are you doing it? Now, think about what it would take to automate this task, right? If we want to automate it, so you don't need to sit in front of the computer labeling each one as the cat or not the cat. I'm actually pretty happy about this feature in Google Photos. I used to meticulously label all my photos. It would take me forever. Whereas now I've stopped doing it because I can just put them all in the cloud, and then when I want to look up one of my friends, I can type in that friend's name and it pulls up all the photos. So very handy. But how is that task being done and how would we automate it? So think about this. You got to get that input of pixels to say the output cat. And in traditional programming, I bet some of you have a programming background here, how would you do this task? You would have to communicate with the universe, am I right? To think really hard about how to convert pixels into cat. And then you would have to handcraft what to do with each pixel, like what to do with the first pixel on the top and the second one next to it and so forth. That's pretty hard to do for this situation. It's hard to explain yourself the traditional way with instructions. Here's what to do with every pixel. And that's what traditional programming is. Now here's the difference between machine learning, AI, I'm using them interchangeably here, versus traditional programming. In the past, you got to explain yourself with instructions. But think about our cats. You don't want to have to come up with what to do with each pixel. You would much rather say, here's a bunch of cats, here's a bunch of not cats, now you go figure it out. So what you're doing, that's the essence of machine learning, is precisely that kind of explanation. Instead of using instructions, you use examples to express your wishes. That is it. If you want one slide that tells you what machine learning and artificial intelligence are, it is this. That's all it is. That's why I also like to dispel some of this sci-fi hype. And I like to say, instead of AI, why don't we call it what we should call it, which is thing labeling with examples. And then every time you want to come up with some doom and gloom scenarios, just instead of saying robot, put thing labeling with example and see if it sounds as grand. So yeah, explaining your wishes with examples, that's what machine learning is all about. Now this is actually incredibly powerful because we as humans, when we communicate with one another, we have both of these modes of communication. Sometimes we want to tell someone explicitly what to do, and sometimes we want to say, here, watch me do it a few times, and you learn by watching me. We have both modes with one another. We like to pick which mode to use in which situation. But with computers, with traditional programming, we could only use one. Explicit instructions, or you can't automate the task. Machine learning and AI, they unlock this second mode of communication with computers. That is a powerful thing. I don't know why we keep appealing to sci-fi, because what more do you need? I mean, some tasks are so hard to come up with instructions for that those instructions are effectively ineffable. How do you wrap your head around what to do with these pixels to get cat? Well, AI and machine learning, they are about automating the ineffable. It does not matter that you yourself cannot come up with the solution. If you find the right examples, then maybe you can explain yourself with examples and get the solution anyway. So this is a fundamental leap in human progress. And it's some incredible stuff. Let me also show you how it works, because there's a lot of over-mystification of this space, when really it should just be explained like 2 + 2 on people's fingers, so that's what I'm going to do. We use the cat, not cat example, but I'm going to change it up a little and use my kitchen analogy. We need to go from ingredients, inputs, to outputs, which are dishes like pizza. And something has to happen in the meantime. We're going to need a kitchen with appliances to play in. We're going to want to create recipes, and then we are going to send ingredients through these recipes to get pizza. This is actually a perfect analogy for machine learning, where all of our objects, ingredients, appliances, recipes, and dishes map to these fancier concepts in data science, where data is simply your ingredients. Your algorithms are like those microwaves and blenders and whatnot in your kitchen. A model is just a fancy word for recipe. In fact, I've always allowed my students just to use the word recipe because, come on, let's speak English, or whatever you prefer to speak, but not math. And finally, predictions or labels or outputs, those are our dishes. So how does this work? In comes some ingredients, and we can visualize those ingredients by mapping them out. Maybe the ingredient information is like how much salt and how much sweetness or something like that. So then where the points fall depends on the particular values for our particular ingredients. Cool, we got that scatter. Now what we're going to do, our entire game here, is to make a recipe that separates the red ones from the blue ones. That's the whole thing. It's that intelligent. How would you do it by hand? You got to separate red from blue. That's your goal. Are you thinking about drawing a line? If you're thinking about doing that, that's also what the algorithm would consider doing. And you don't have to use a straight line. You can use all kinds of different shapes for your algorithm. So in fact, all these gobbledygook strange names in machine learning and AI, they simply refer to the selection of what shape of thing you're trying to shove through your data. So let's suppose that I pick the third one, and I'm going to do that in honor of someone I'm going to mention in the talk later, because she's the inventor of this thing. So I pick the third one, and what I do then is, here's my data again, and then I run this algorithm that's saying that my boundary has to be this like curvy thing. And what the algorithm does is it takes the data and it says where then is the most sensible place to put a curvy shape that separates them. So I hope that you see that it's not going to be right along the bottom, it's going to be more like there. And that does a nice job of separating the red from the blue. And then when that algorithm is done running, what comes out is what we've wanted all along, which is a recipe. And how do we read this recipe? Simply, when our next data comes in, if it lands in the red region, call it red. If it lands in the blue region, call it blue. Literally, there is nothing more to it than this. And there is a lot of tinkering, just as in the kitchen. If you are making a new recipe for something that doesn't exist yet, like Michelin star quality, calorie-free vegan pizza, how long is that going to take you to develop? Is it even possible? Is it even going to taste as good as you need? You don't know, and you can't go find in a textbook what that recipe is. It doesn't exist. And you can't find the process and the guarantee and the amount of time that it takes. So what are you going to have to do? You're going to get a bunch of different appliances. You're going to get a bunch of different ingredients. You're going to set yourself a time limit. That's actually a really important part of machine learning leadership. Set a time limit for how much the project has. And then you're going to go and tinker. And in fact, the personality that I most recommend for machine learning engineers is not perfectionists, failure-tolerant people, because there's going to be a lot of failure, right? Every time you try and make this recipe, your first one isn't going to be delicious enough. That's fine. Pick yourself up, dust yourself off, try something else. Try and try and try, and every time, just as in the kitchen, you're going to find something out that tells you a little bit about what you might like to try next. And so it's a whole lot of stumbling around in the dark until hopefully you find your solution. Or maybe you don't. But if you do, you might now suddenly have an awesome recipe that never existed before that helps your business. So very similar to the kitchen. And as with the kitchen also, and this is one of the things that I'm always making a lot of fuss about when I give talks, you think you've got the recipe. Some nerds in your kitchen tasted that recipe. You have customers, and you're thinking about adding this recipe to the menu. Maybe actually conduct some proper taste tests first. And do some rigorous statistical testing to make sure that this thing does actually taste as well as you need it to. And now, because we're automating the ineffable, folks, we expect that those recipes are going to be too complicated to read. We won't just be able to read the recipe and by eye tell, oh yeah, that's going to taste great. So what do? We don't worry about that. Instead, we cook it a whole bunch of times and we do the actual tasting. Instead of trying to infer from the written recipe how it works and whether it tastes good, we actually taste it. That's the key. Now, that's a little different from how our rhetoric used to be with solving problems. If everything was always instructions, and we could only ever solve tasks whose instructions we fully understood, by the way, that's the low-hanging fruit, right? The tasks whose instructions are so simple they fit in my head. Oh dear. When we worked with that low-hanging fruit, of course we could understand all of it. So we got used to understanding that tiny simplistic thing, and that's how we also evaluate it. But when things get complicated, when it is a big long recipe and you can't read it and know if it tastes good, then you must take the other approach. Now you have to start conducting the taste tests, so that's what will keep you safe. Now here's a brief history of our evolution of automation with data. So we start out with no recipes of any kind made, and everything has to be kind of reinvented from scratch every time. Every time you're going to do a task, it's going to be you doing it some new way, vaguely based on intuition, may or may not be related to the last times you did it. Until we get the ability to handcraft our recipes as code. And this is the first programmer. We're going to do a little bit of famous data scientists bingo. Any data scientists in my audience or data enthusiasts? Well, okay, not many hands there, so then I'm going to have to help you through this bingo. Anyone knows who that is, though? Okay, I see one hand. This is the poet Lord Byron's daughter, Ada, Countess of Lovelace, and she is actually the first programmer in the world ever in history was a woman, Ada. And so from her contribution is born the art of programming, which is essentially coming up with instructions by thinking hard about the problem, writing them down so that a computer can carry them out. But here's the thing. Poor Ada is not using data of any kind. So where is she getting this instruction from? It's kind of like some intuition, vaguely, maybe. Wouldn't it be better if she could formally, carefully look at some facts about her world and maybe use that to directly inspire the recipe? Now that is what analytics is all about, to inspire recipes with data. And this person, I guarantee that you will recognize her name, but you don't know that she's actually famous for her contributions to analytics and that she saved a lot of lives with her innovative infographics. So who is this? This is Florence Nightingale. So Florence Nightingale you probably know as the mother of the nursing profession, but she's actually a pretty cool statistician and analyst who saved a lot of lives, pointing out to the British government that maybe hand washing and sanitation was a thing you should worry about by looking at the leading causes of death in hospitals during the Crimean War. But look, what we've got right now is we've got Florence looking at data, doing analytics, and then using that to inspire a solution, and then telling her colleague Ada how to code that up. But in between the two of them, we have to sort of upload it in one of their brains, and then speak it out, and then upload it into the other one's brain, and then only turn it into code. What if we could automate that whole process? What if we could make algorithms to do that? And so now we're a little bit closer to modern times. This is actually my old boss, Corinna Cortez, head of research in Google New York. And she is the co-inventor of a whole class of algorithms related to the one that we earlier fitted through our data, that polynomial support vector machine. But what she's making, what she's contributing to this space, is essentially the microwave or the blender. She's making the appliances, and that's great. Now you have appliances to use. But what we don't yet have in our discussion is the culinary science side of things. How do you actually go from ingredients to effective, well-tested, safe solutions? How do you think about this end-to-end process? Not just the engineering of the microwave, but the actual cooking at scale, running McDonald's. And that is data science and decision intelligence, what I work on and what my friend Hilary Mason, who is a really famous data scientist and one of the pioneers of using that term for our profession. So Hilary would focus much more than just on making that algorithm. She would focus on what are we cooking? How should we cook it? How should we iterate? How do we know if we've succeeded? Now, in this space, you've seen its brief history, there is a lot of, I don't know, pomp and circumstance, let's just call it that. There is a lot of use of really big language where the big language doesn't belong. I mean, I've taught you pretty much most of it with simple words, and that was fine. But what I find is that AI, I mean, even think about this term, artificial intelligence. It's got such intimidating naming, or like machine learning. It should be called thing labeling with examples. Now, that's kind of good for marketing, but it also has an interesting effect on people thinking about entering the space. You think it's really difficult and big, and if you're easily intimidated, then you want to run away. And that maybe creates an interesting work environment full of people who are insufficiently intimidated by language. It could be a little bit of a strange work environment. I mean, I remember when I started looking at this stuff, and I saw terms like confusion matrix. And I was like, whoa, what is this thing? And then it's defined with math, and you're like, I'm not even going to read it because it's hard. Except when you do read it, you're like, what that actually is a results table. Why don't you just call it a results table? It's literally a results table, and now you go use these terms like confusion matrix. So it's It's a very intimidating in its word space, and it's got a lot of sci-fi jargon. And I don't think that's helpful in many ways. See, there are dangers in this space. And there are things that you should worry about. And I'll tell you what they are in a moment. But they're almost never what people actually worry about. Because people are too busy being distracted by science fiction and distracted by this idea of autonomous humanoid things. In fact, I just want to remind you that maybe we shouldn't even talk about autonomous anything. Maybe let's call it perpetual, because all technology comes from us. It's not autonomous of us. It's just a big lever that extends the wishes of whoever built it. There's no such thing as technology that is separate from us. But what it does, though, is it extends us. It is a tool that extends our abilities. And I would say that the danger with it, there are two. One of them is a danger and an ethics of scale. If 3 of you in this room suddenly grew into 400-meter tall mechs, and you tried to walk around without any training in how to be that big, you would probably hurt a lot of what's around you. So if you start to grow, and if you start to wield this huge lever, and AI is not the only technology that is a tool for extending our effect on the world. When you start to wield such levers, you need the skills to wield them responsibly. And science fiction is a really dangerous distraction here, because you think that you're worrying about the right stuff, but you're not. So a very quick exercise as I end up. I want to ask you to raise your hand if you like my caption for these images. The first one I will easily raise my hand for. I like this. Human and human working together. I think that this is an accurate description. Yeah, we're doing some aerobics. Hopefully everyone's doing this right. Next one. Human and donkey working together. I'm on the fence, quite frankly. Maybe I'll give this one it. How about the next one? Human and bike working together. Fewer hands I see. Very few takers, from almost everyone to fewer. How about this? Human and calculator working together. Okay, fewer again. Human and hammer working together to hammer the point home, and I see 2 hands. Human and AI working together. Very few hands now. Now the thing is, if I had shown you this one right at the beginning, do you think I would have gotten more hands? Yeah. There was a slight, subtle point that I was making, not so subtly, which is that AI is a tool. And it makes no sense to say working, at least to me, there was some dissenting voices throughout my demonstration, but at least to me, it makes no sense to say that we're working together with our tools. We are doing the working, we are making the choices, we humans. And our tools are just there to be used. And AI is a tool like any other. And like any other tool, we must use it responsibly. But we cannot shove responsibility to it and talk about it as an entity that has bias and does things. It is its users and creators that are responsible. And so back to basics then. Machine learning turns patterns into recipes. That's what it does. Patterns in examples. So in order to do this well, you're going to need to think about having good examples. And so the second part that I'm worried about has to do with our role as machine teachers. If we're dealing with machine learning, who's thinking about machine teaching? These examples that we use, they are essentially textbooks. Datasets are textbooks. Textbooks are datasets. It's the same thing, except that textbooks are not electronic, so they're hard to analyze the data in. But it's kind of the same thing. Whatever applies to a textbook also applies to a dataset. When you laugh when someone says, it's in a book, so it must be true, and then you don't laugh when someone says, the data said so, I don't get it, because it is the same thing there. So, like textbooks, datasets are authored by humans. They are collected according to instructions that humans make. And so there's a whole discussion around AI bias. AI is not a person. We can't blame AI. Now think about this. You, the humans, have decided to use a textbook to teach your student. That textbook was authored by a human with horrible prejudices. What do you think your student's going to learn? And whose fault is that? I would actually put that fault mostly on the teacher. Because, friends, what kind of teacher assigns a student a textbook without opening the textbook first, without thinking who the author was, without checking a few of the examples to see if they were okay, if this is actually what we want the student to be learning? A textbook could say mathematics, and it could say mathematics. One of them is university calculus, one of them is second grade elementary school mathematics. It says the same thing on the cover. You've got to open it as the teacher. Make sure that's what you want your student to learn. So every time there are these AI bias issues, that tends to be because the teacher did not open it up and check. And it was authored by some people either for a different purpose than what the teacher wanted it to be used for, or by some people with some horrible prejudices. So looking at your data, analytics, what Florence Nightingale did, that is a huge part of how we stay safe and make sure that we get sensible solutions and not have AI bias problems. But there's another piece as well. What if you did check, but you have exactly the same horrible prejudices as the author? Well, then you're going to give the book the green light, and then we're only going to discover problems when the student learns some horrible things and then talks about them in public. Now, how do we prevent that situation? We prevent that situation with diversity. The way that you catch these things is to have more than one person take a look and see if the textbook is good, and more than one person have a hand in authoring the textbook. And the more diverse those perspectives are, the more likely we are to catch the badness. So in AI, diversity is not a nice to have. It's actually a must have. Otherwise you mess up, and you mess up wielding these really big levers. So you need this diversity of perspectives. And you need to remember just how human this is. So let's do it in reverse with our heroes here. You're going to have to set a wise objective for your students. It is subjective. The objective is always subjective here. What do you want your student to learn? What task do you want your machine system to perform? Then you're going to have to find good tools that others have built, because if you try to reinvent everything from scratch, solving any problem is going to take too long. Then please apply analytics and look at what you're asking your student to learn and get diverse perspectives on that. And remember that the data sets in the first place are collected by people. They are selective memories. They are not reality. Today you experienced reality. But if I ask you to tell me how many people with a blue t-shirt you saw, and you saw them, well, you didn't choose to pay attention to that, and you didn't choose to record it in your data set. So what the authors found important is what's going to be in there, and that may or may not be the textbook that you want. So please be thoughtful about that. We talk a lot about machine learning. What we need to start talking much more about is machine teaching. We've been so fascinated with the ability to learn from patterns. And we've made so much fuss about all the math and all the fun sci-fi there. But that more common sense, yet common sense is quite often not so common, and it's missing that common sense side of, now that these things can learn, what will we teach them? That part is not addressed enough, and that's the part I want us to start talking about. I want us to see just how human this is all the way through. Not push responsibility to a tangle of wires. And start stepping up, all of us, to speak sensibly about teaching. We don't need a PhD in the mathematics to think sensibly about this. We need to ask the same questions that any teacher would. And if we do that, that is how we build a brighter AI future together. These technologies are cool. We can make magical things with them. We can automate the ineffable. But we need people to teach responsibly. So thank you very much.